Okay, let's take a look at section 5.5, which is about proving triangle congruence by SSS, which is side, side, side. So far we've taken a look uh, in section 5.3, I believe, which was about proving triangles congruent by side, angle, side. So there are several other ways for us to prove two triangles to be congruent, and today it'll be side, side, side. Before we get to there, let's take a look at this triangle that I have, and we're going to talk about, well, in this triangle, hopefully you see what type of a triangle it is, and it looks like a right triangle, and because it is. So specifically, we're going to be looking at this right triangle right here, and in the right triangle, two of the sides are called legs. And then the side opposite of the 90-degree angle is your hypotenuse. Okay, so the hypotenuse is very specific. It's only in one spot, and that one spot is the side opposite of the 90-degree angle. And in a right triangle, that side, the hypotenuse, is always going to be the longest side. Okay, so remember that. The longest side in a right triangle will be the hypotenuse. The two legs will be the smallest. Kind of adding on to that, remember, if this angle right here is 90 degrees, then these two acute angles will add up to be 90. So if that's the case, remember, these two angles right here are going to be less than 90, or they're going to be acute, and therefore, remember, the bigger the angle, the bigger the opposite side. So if these angles are smaller, then these sides opposite of them will be small or small as well. So the idea behind side, 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 or SSS is pretty simple. Three sides of a triangle are congruent to three sides of the other triangle. All right, if that is true, then we go ahead and have ourselves two congruent triangles. But once again, here's the thing. It's important to note that the order in which these letters are written in our similarity statement, they're written in a specific way. So right here, if I look, I should know that AB is going to be congruent to DE. BC is congruent to EF. And side AC is congruent to side DF. And that's all based on just looking at the similarity statement. You don't even have to look at this diagram to know which sides are congruent because of this congruent statement. All right, so sorry, not similarity, but our congruence statement. And let me take that back. Because sometimes the diagrams may look like they are congruent, but the order of the letters are not in which they are written, like in our congruent statement. Therefore, it becomes the triangles are not congruent. In theorem 5.9, we have this next theorem of hypotenuse-leg congruence theorem. And so this one, you can only use this theorem when we're using a right triangle. I have that there, right there in red. Okay, only used for a right triangle. So what they're saying is that if I have the hypotenuse of both triangles are congruent and one leg is congruent, then we can go ahead and prove that the two triangles are congruent. All right, as simple as that. All right, let's go ahead and move on and put it all together. So in number one, it says decide whether the congruent statement is true. Well, in order for us to decide that, we have to see at which sides are congruent. So I'm looking right here. AB is supposed to be congruent to ED. Okay, so I look at AB, I look at ED. Okay, good. They are congruent because they have that single hash mark. So let me go ahead and put that down. AB is congruent to ED because that's what you're going to be doing in a proof anyways. And then let's see, we're supposed to have BC congruent to DC. So let's see right here. I've got BC is congruent to DC. They are congruent. They've got the hash mark, so let's add that down. And then we have right here, the last part is AC, right? AC is supposed to be congruent to EC. So AC congruent to EC, that looks good right there. And so since we have three sides of each triangle to be congruent, I can go ahead and write my congruent statement right here or decide whether it's true, and that statement happens to be true because we have all three sides that correspond with each other are congruent. All right. So let's take a look at number 2. All right, let's see what's supposed to be congruent here. We got KG. K to G is supposed to be congruent with H to K, or sorry, HJ. So I'm looking at the diagram. That's true. Let's see right here. We got GH is congruent to JK. So GH right here, congruent to JK. Fantastic. And then the last one right here is supposed to be HK and HK. That looks congruent because it's the same side in both. So let's say HK is congruent to HK. And if we were to, in a proof, give a reason for this or an explanation, remember that would be the reflexive property. All right, so we got three sides congruent. This statement of triangle KGH congruent to triangle HJK is true. Let's go ahead and move on to number 3. All right, so let's see. We have UV is supposed to be congruent to XY. So let's look at UV right there, XY. Great. So we got UV congruent to XY. We have VW right here. VW is supposed to be congruent to YZ. Now there's VW, here's YZ. Uh-oh, they don't look congruent, right? UV is not congruent to YZ, which they're supposed to be. So see, that's why it's important. The diagram looks like they're exactly congruent, but the order of the letters and where they are placed in each diagram don't correspond with with each side. And so right here, remember, we have 3 hash marks for VW. We have 2 hash marks for YZ. And so right here, this is no. Okay. The main reason for it is that these two sides, UV and YZ, should be congruent, and they're not. So I think hopefully at this point you get the idea on how to prove these triangles to be congruent using side, side, side. All right, let's see right here. Let's go ahead and move on to number 6. Let's take a look at this proof. Let's put it all together. Put all the pieces together right here. Now, there's a lot of stuff going on. It says, redraw the angle so that they are side by side with corresponding parts in the same position, then write a proof. You don't necessarily have to do that. A lot of the information is there. So let's see what we could put right here. Start off, once again, let's put what's given. So we can go ahead and say that B is the midpoint of segment CD. And let's go ahead and add AB is congruent to EB. angle C and angle D are right angles. So the reason for that, let's go ahead and put that that is all given. And let's see in our diagram right here, if B right here is the midpoint of C to D, hopefully we can go ahead and say, I think it's safe to say that BC is congruent to BD, right? Because if something is in the middle of a segment, it's going to split it in half. So let's go ahead right here. That'll help me with our second statement. Let's go ahead and put segment BC congruent to segment BD. We need a reason for that. Let's go ahead and use what they give us, and we'll say definition of a midpoint. Because remember, a midpoint will be in the middle of that segment, right? And then it'll split it in half or give you two congruent segments. So we have that right there. What else can we say? All right, let's see. Remember in the diagram, or actually in what's in the given, it says that angle C and angle D are right angles. So what we could say right here is that triangle ABC and triangle EBD, since they are both congruent, and if you look right there, they said that they said they're right angles. We can go ahead and say that those two are right triangles. I'll go ahead and abbreviate that, right triangles. And the reason for this, let's go ahead and put definition of a right triangle. So now the reason why I'm making sure that and including into our proof that we have a right triangle and we have two sides right here that are congruent, or two pairs of sides that are congruent, is because, well, remember, one of their theorems was specifically used for a right triangle. And so for the last part right here, in step 4 or statement 4, I can go ahead and say that triangle ABC is congruent to triangle EBD. Because look, we have a right triangle. I've got hypotenuse that happens to be congruent. I've got a pair of legs that happen to be congruent with each other. And so I can go ahead and say that these two triangles are congruent using the hypotenuse-leg congruence theorem. And there you go with number 6. All right, let's try number 7 here. All right, so they give us a lot of information. And so we're going to try to put it all together. I highlighted each triangle, or the two triangles we're trying to prove, to help you understand what exactly we're looking at. Because sometimes it's, you want to know what direction we're going towards. And our story right here is supposed to be that triangle EFG is supposed to be congruent to triangle HIJ. And so you can see the two triangles highlighted with the two different colors there. So step 1 right here, we're going to put all our given. So we got like IE is congruent to EJ, congruent to JL, congruent to LH, etc. Okay, so I want to go ahead and put that down right here. I know this is not the best handwriting, not my best effort, but that's the given statement. It's all there. You know what it is. So where can we go next? How can I prove that these two triangles are congruent? Well, remember, what they gave us are these small little segments. They're not really the entire length of the triangle or each side of the triangle. So can we make that happen? We certainly can. And this is what I'm going to go ahead and do. In statement 2, I'm trying to justify that like IH is congruent to, let's say, IH being right here. We need to make sure it's congruent to EF. So IH congruent to EF in our diagram. Well, how am I going to do that? Well, remember, there's a thing that we learned early on. Let's go ahead and start off with this. I could say that, let's say, EF, that segment is equal to EK plus KF. All right? We're saying once again, EK plus KF is equal to the whole entire thing of E to F. Let's go next. We have FG is equal to, put FH plus HG. All right, so there's the bottom segment. And then let's go ahead and add right here as well that G to E is equal to EL plus LG. All right, so we got that part there. Let's take a look at the next triangle, the one that was in blue. Probably should have used the red for this and then blue for what's coming up. We'll rotate it around, but it's okay. So we have now, let's go ahead and HI. So segment HI is going to be equal to HK plus KI. And we have IJ. That's equal to IE plus EJ. And then we have right there, the last side is JH, and that is equal to JL plus LH. So all this right here, I can go ahead and justify it by saying this is segment addition postulate. Right? Remember, two small segments add up together equals the big segment. So that's what we're going to put for number 2. All right. For the next part, here's what let's see what else we could do next. Okay? We have to somehow think of a way where we can combine everything together. How can I make a connection of combining parts together right here? And let's go up to the top. Remember in our first statement right here, all of these segments, they're all congruent to each other. Right? It says that, look, all IE, EJ, JL, LH, etc., they are all congruent to one another. So in statement 3 right here, here's what I'm going to say. I've got right here, let's say that's segment EF. Okay? I'm going to say that's equal to, what if I take segment EK and multiply it by 2? Right? Because EK is congruent to KF according to our list of segments up in the given. So I'm going to go ahead and start right here. EF is equal to 2 times EK. Let's go ahead and do that same thing with FG. I want to say that FG is equal to 2 times segment EK. I want to also put GE is equal to 2 times segment EK. And once again, why can I do that? Well, that's going to be our reason. And what I'm actually doing is using the substitution property. Because once again, I know that Fj right here is equal to Ek according to our list of given statements, right? Of given things that are congruent. So I want to take 2 times Ek right there. Let's do the same thing down below with the other triangle. We have Hi is going to be equal to 2 times Ek. Let's see. Next up we have Ij is equal to 2 times Ek, and JH is equal to 2 times Ek. And there you go, we've got substitution property. So, we've got this part down. Next up, how could I make some connections between all of these segments? Can I? Well, you sure can. In statement 4, if you think about looking at these 3 statements right here, or even like these 2, if I have A, B, B, and C, remember that? We got ourselves transitive property. So what I can go ahead and say right here, for example, is that like HI, that's congruent to EF, right? If I look at HI and EF, I could say A, B, B, C, A, C, and make that connection of EF is congruent to HI. Now, why do I want to do that? Because take a look. What are we trying to prove? 2 triangles to be congruent, and one of those 2 sides is EF and HI. So that's why I'm setting up these 2 right here in my congruent statement. Let's go ahead. Next up, we can make the connection between these 2. And so I can go ahead and say that FG is congruent to IJ. And then right here, I could say that GE is congruent to JH. And all of this because of the transitive property. So now that we have 3 sides of each, triangle to be congruent, we can go ahead and conclude this with step 5 and say that triangle EFG is congruent to triangle HIJ. And guess what? Because we now know that all sides of each triangle are corresponding sides of each triangle are congruent. Okay, so this last proof right here is a little more challenging. There's a lot of stuff that obviously was covered, and like I said, everything that you're on all these proofs, you're going to have to recall stuff from previous chapters and try to make these connections. And so you're going to see stuff like this over and over, whether it's segment addition or angle addition, in these proofs. Okay, so it's important. Don't try to reason with yourself. And there's so much information. That's why I kept saying, maybe make flashcards as we went along with each chapter to help you have a good recollection and memory of all the different theorems that are out there. So if you still need to do that, it's not too late, right? Because there's more proofs coming up in this chapter. All right, and here's the end of 5.5.